Hi, my name is Erin Roy and I'm a senior psychology major at UNC. I've mentored for Chem 101 4 times before and I'd like to mentor for Chem 101 again this semester. A fun fact about me is that I enjoy baking in my free time. So the problem that we're going to be doing today is figuring out whether nitrate is polar or nonpolar. And to do this, we need to draw the Lewis structure of nitrate. And to start drawing the Lewis structure, I always like to start by tallying the valence electrons. So you know that nitrogen has 5, oxygen has 6, but there's 3 oxygens. And this negative charge counts as having an extra valence electron. So when we add this up, that equals 24 valence electrons. So I'm going to start by putting nitrogen in the middle because it's the least electronegative atom. And we used up 6 valence electrons, so now we have 18 left. And I'm going to use those by putting valence electrons on each of the oxygens. So that leaves us with negative formal charges on each of the oxygens and a +2 formal charge on the nitrogen. And the nitrogen also has an unfilled octet, so we know that this is definitely not the best resonance structure that we can draw for nitrate. So to fix this, I'm going to move one of these valence electrons and make a double bond to the nitrogen. So that leaves us with this structure that has no formal charge on this oxygen, and now the nitrogen only has a +1. It might be tempting to move this valence electron pair and make another double bond to the nitrogen because that would get rid of this formal charge and this formal charge, but that would leave nitrogen with an expanded octet, and nitrogen can't have an expanded octet because it's in period 2. So this looks like the best resonance structure that we can get, and we can draw 3 equivalent resonance structures of it. So now we're left with these 3 resonance structures, and each of these resonance structures separately does not exist. There are only 3 different ways of representing the molecule. The best, most accurate way to represent the molecule is by drawing the resonance hybrid by combining these 3. So that leaves us with partial double bonds to each of the oxygens, partial negative charges on each oxygen, and the nitrogen always has a +1 formal charge. So because this resonance hybrid is symmetrical, that means that nitrate is nonpolar. We can also show that nitrate is nonpolar by drawing the bond dipoles and seeing if they cancel. So we know that the bond dipole for this bond points this way because the bond dipole points towards the most electronegative atom, and the bond dipole for this points this way, and the bond dipole for this bond points that way. I'm going to redraw the bond dipoles, drawing these into their vector components just so it's easier to see if they cancel or not. So because these are equal in magnitude and they point in opposite directions, they're going to cancel with each other. And adding these together equals the magnitude of this one, and they point in opposite directions, so we know that those cancel as well. Because all of the bond dipoles cancel, we know that this molecule is nonpolar.